Hello everybody. I like to thank first of all everyone for coming over here, giving your precious time to me for your math revision. Uh, just before we start, just a brief introduction about how you can make the most out of this particular program. The mission statement says that you can score a 70 plus in maths at JEE Mains in a span of 2 months. Right, so this is not an overstatement that I am making over here. This is quite much possible. You can do it provided you work very hard for it. Right, it is quite much possible. Yes, you can do it, right? But it requires a lot of hard work and determination and an effort of more than 10 hours a day from now on to get to this particular level. And I hope you understand that if you score a 70 plus in maths, your score is bound to get 180 plus, because that is how the trend is. And supposedly that you don't flunk in chemistry, but yes, that is what I expect you people to score if you are having 70 plus in maths. And given that score, you would definitely get into the required or the desired NIT in the country. 180 in fact is a brilliant score to get even computer science at some of those prestigious NITs, which I think might be the requirement of many watching this video. So how we are going to make this productive? So first of all, it is very important to get inside the examination point of view, by which I mean that I have attached a file saying the weightage of each chapter, right? So you can just go over it, see what is the composition of questions that are being asked in the IIT JEE Mains exam, and you will find that the trend is very common. So the questions that are being asked have a particular category, a particular number of questions are being asked from every chapter for the last 5 years. So the trend is very obvious. That is the reason I have given a 5-year analysis of the questions that are being asked on a chapter scale. So if you see that in class 11th, the important topic is basically sequence and series and the coordinate geometry, and that's the reason that we are going to start with the algebra part and specifically with sequence and series. Right, so you will get a fair idea about which topics you want to focus your energy on. Also, please note that not all the topics are of the same difficulty level, right? This is very crucial. So especially if I talk about class 11th, because that is the major hurdle for you people, where you feel that you are completely lost with your class 11 syllabus, don't worry a bit, because class 11th topics are relatively very easy in the paper. You, in fact, if let's say if 12 or 15 questions are being asked from class 11, so that is a range of 12 to 15 questions, so it might vary from 15 to 12. So let's say when if 12 questions are being asked from class 11th, believe me, 9 or 10 out of them will be easy, which you can do it in a span of those 2 months. And for those 2-3 questions which are tough, need not bother. We are not even targeting 120 for these 2 months, right? So don't worry about them. So our target of this particular course is to figure out, can we solve those easy and moderate questions given the time frame we have with us, especially since the board exam has been delayed. So this could be a trade-off, because yes, the people who are writing exam on 2nd of April will get very less time to prepare or basically revise after their board exams. But yes, as a trade-off, I say the good point is that you're getting complete 50 odd days to prepare before your board exam starts. So this is a very good point in my opinion, right? So if you can crack the exam code, you will not face any difficulty in the whole tenure of these 2 months, right? The second step is watch videos. I have given the schedule to you people that how I will be covering the videos. First of all, the videos will be put every night at 9 p.m. There's a logic behind this, because I understand you people might be going to schools for your pre-boards, or going for your Viva practicals, or you're going to some coaching institute. So relatively you people are free at 9. So that is the logic that we have put out the videos at 9. The videos may vary from 1 hour to 2 hour, anywhere between 1 hour and 2 hour, depending on the content that I prepare, right? So some chapters might require me to work on for 2 hours with you guys, and some will eventually end up in 1 hour, though I'll try to cover them, most of them, in 1 hour, right? and you can watch the videos on the YouTube or the Facebook link that I am going to provide you on your email. So first of all, keep your email updated all the time. In case if you have not given your email IDs to us, just go on the website, fill your email ID so that we can get live or we can get you updated coverage of our videos over there, right? And the third step would be that you will definitely be requiring worksheets to work on. And I understand there is no point doing 500 questions at this point of time from a particular chapter. That's not worthy enough. So what I'll be doing, so for example, I teach a particular topic today and I'll be giving you around 80 to 100 questions to practice on, which will be of a moderate level so that you can easily solve them, get into the mode of solving maths problem, not just getting worried about by not solving a particular problem. So they would be easy, they would be medium, but not particularly tough. So that is what I am focusing on, because we know that we are going to focus IIT mains kind of examinations from this point onwards, right? So again, for this I would be requiring your correct email ID. So it is better if you can, if you are not sure whether you have filled your email ID correctly, just go on to the website once again and fill the email ID correctly, because all the worksheet will be sent over the email IDs. And coming about to the doubts part, so obviously when you will go through the lecture, you might find something which you are not able to understand, and also there could be some difficulty in solving the problems. I cannot assure you that I would be able to cover the entire doubts of your worksheets, but yes, what you people can do, I'll be sending you a Facebook page link also tonight, where you can start asking everybody or your peer group about the particular problems given in the worksheet, and then maybe I could take a doubt class which will cover the majority of the questions that are being put up on the page. Just go through the schedule once again. So I have deliberately given a Sunday break every week, which is just for revising what we have learned the entire week. And if I get sufficient doubts for which I need to get in touch with you people, so for the doubts, videos would be put up on Sundays. So that is how we are going to cover this particular course. I hope to finish this course by 28th of February. That is the deadline that I have in my mind. So I hope I am able to finish up till that level. And this is the deadline that I'm going to target. And I'll also try that I can give you more free goods, free stuffs, if I find anything which is more relevant than what I'm giving at this point of time. So just sit back, watch the videos, start learning, start working hard if you want to score 70 plus in maths. Best wishes from my side. Alright, so today we'll be starting with the topic sequence and series. I hope you enjoy that session. Okay students, let's start the first topic that we are going to cover in this crash course. So the first topic that we are going to do as per the schedule is sequence of series. And as you can see from the weightage sheet that I have given to you, this is one of the most crucial topics of class 11th, right? Because every year 2 questions are being asked from this particular chapter, and more importantly, more questions of class 12th are also associated with sequence and series. So the importance is prime for this particular topic, and that is the reason that I have taken this topic at the beginning of this course. So as per the JEE Main syllabus, so they say that they are going to cover these 5 topics that are written over here, that is APGP, insertion of arithmetic means and geometric means, relation between AM and GM, and some of series which we call summation n square, and summation n cube, and this is what we call as AGP, that is arithmetic geometric progression, right? So by far this is very convenient to do, not a very lengthy list of topics, though this is a very difficult topic as I talk about IIT Advanced, but still we are just covering the mains portion. I guess this is pretty much doable, right? Let me just show you what we are going to do for this particular topic. So apart from these 5 topics that are already there in the syllabus, we are going to cover these 3 more topics, that is harmonic progression, AM-GM inequality, and some special series using VN method. I'll tell you what the VN method is, right? So these 3 topics we will also cover. Why we are covering HP, which is despite not in your syllabus, but still we'll do it. Why? Because in options, whenever you solve questions, you might find options like this AP, and the second option might be GP. Third option here then comes out to be HP. So if you are not sure about what is HP, you will never be able to do C option here. So that is the purpose of going through HP. Though we'll not do it in detail, we'll just see the basics of HP and then we'll move ahead. Right? Okay. Okay, so let's start the first topic that we have to cover as per se our syllabus, that is arithmetic progression, right? Let me tell you the purpose of this series. So the lectures that we are going to cover in the entire course are not to teach you the basics of each and everything. We don't have the time to cover the basics. So what we are going to do is that we are going to take up some good questions and then figure out how to apply the basic concepts that you have already learned over the class 11th and class 12th period on these particular questions. So I'm not going to revise the basic formulas for you in this series. That is, I guess, is a wastage of time. We'll directly put onto the questions as I have taken this question here, and we'll try use basics in these, right? So let's start with the first question. We already know what arithmetic progression is. So arithmetic progression is something of this sort. If I talk about the very basic, which you must remember, where we talk about this D as common difference, right? So every term is being added by a constant number, which remains same for the entire AP. So this is actually what is called as AP. We also remember the formula for AN, that is A1 plus N minus 1D. This everybody knows. SN, so A1 plus AN. Yeah, remember AN, A1 plus AN by 2, right? Or we can say this is also equal to N by 2, 2A plus N minus 1D. Alright, so just going through the basics. But let's see how we'll apply this everything in this particular frame of question. So it says let AN be the, so AN is the nth term. We know this is the formula for the nth term, and it is given as something of this sort. So my target in this entire lecture series is to showcase what you people find difficult while trying the questions. And as I've already mentioned that IIT JEE Main is not very difficult to crack. It's just that you have to be comfortable with what the question is asking. So it says summation A to R is equal to alpha, where R varies from 1 to 100. Right? So this is the particular thing which the question is asking. So now understand what do you mean by the summation sign. Right? So what does summation signs mean here is that start putting the values of R starting from 1 till 100. So what it will become, let's see. So A, if you put R equal to 1 here, it will be 2. If you put R as 2, then it will become 4, and so on till it will go till A 200. The summation is given to be alpha, right? So this is the thing which is given to us. The other thing which is given here is that summation A to R minus 1 is given to be beta. So if we now do the same thing with this, this becomes that A1 plus A3 up till what, put just 100 over here, you will get A199 is equal to beta, right? Another important thing to remember from this particular thing is that 2R generally means all even numbers. So this 2R here is even numbers, and 2R minus 1 should represent all odd numbers. So this sum of all even terms of this particular AP. Beta is representing sum of all odd terms of this particular series. What we need to find is, we need to find the common difference of the AP. Let me just rub this portion which is not required to get ahead of the question. Okay, so now we know what do you mean by alpha. So alpha is nothing but A2 plus A4 up till A200. We know that what is beta. So beta is A1, A3, and it will go on till so A199. Now our target is to find D. So what is D? So D is nothing but difference of two consecutive terms if we start writing like this. And this could be valid for what? A200 also, A200 minus A199. Right? On the onset, this problem looks to be a bit difficult, but believe me, this is one of the most easiest things that you can ask in the paper. So we are required to find common difference of the AP. We are given these two series, and if we just check at the answers, that what are the answers here, they are given in the form of alpha and beta, right? All the four options. So somewhere down the line, alpha and beta has to be used in finding the D. Now let's see how we do that. Another very important thing which we can grasp from the question itself, every option has alpha minus beta or beta minus alpha here, right? So let's see what is alpha minus beta. Alpha minus beta would become a2 minus a1 plus a4 minus a3, and what will be the last term here? Last term would become a200 minus a19, right? So now what is this term? This becomes D, this becomes D, and this also becomes D. And how many terms are there? So in total there were 200 terms, and we have started to pair them, right? So how many pairs will be there? If there are 200 terms, pair means taken two at a time. Out of 200, how many pairs would be there? There would be, exactly, there would be 100 terms, right, bang on. So what this actually becomes is alpha minus beta is equal to 100D, because D will be repeated 100 times, and this gives us our answer that D is nothing but alpha minus beta by 100 is the D, and that is nothing but our second option. That's it. Can you see how simple this problem was? And if I'll tell you that this problem was being asked in AIEEE 2011, then I think I have made my point that the questions that are being asked at this level are really simple. You just have to stick to the question, understand the basic of it, right? Let me take another problem for you to make you sure that you are comfortable in this particular domain, right? Alright, so let's take another problem here. So it says that A1, A2, A3 up till A100 are in AP, and A1 is given to you this time in the question itself. It is given that A1 is 3, right? So A1 is 3, which is given to us, and the SP, that is sum of this progression, is also given to us as again the summation sign. So I hope you are not now wary of this particular sign. I understand that you must have got hold of it from the previous question. So this is given. So what do you mean by this? That SP is sum of terms of this AP. So this actually becomes this. All right. So this will be till AP. That's it. So P is between anything between 1 to 100. For any integer n between 1 to 20, let M be given as M is 5n, right? And we need, if Sn by Sn does not depend on n, then we need to find the value of A2 here. So what do you mean by Sm by Sn? So if we just review our formulas here, so what does the formula say here? So we know that Sn is nothing but sum of first n terms of the AP, which are given by this particular formula, right? We have already done this much. We remember this much. So let's take this problem from here, and if we apply here, so it becomes m by 2, 2a plus m minus 1d, right? And then Sn would become, what would be the Sn part? So Sn would be similarly n by 2, 2a plus, so this is a simple step, right? Now if we see that these two and these two will get cancelled out, similarly we also know that there is a relation between m and n given to us. So what we can say, so this m and n will also cancel out. We'll be left with what? Sorry, not n, but just 5 here, right, by doing the cancellation stuff. And what would this be? Let's say, so this will be 2a plus, let's say, 5n minus 1d. Alright, so in the denominator then we would have 2a plus n minus 1d. Alright, what is given to you in this particular problem? Let's go ahead and take this. So it is given that, so we are given that Sm and Sn, these two things, this ratio does not depend on n. So this is the key to this particular problem. So let's apply this. So if I solve this particular stuff, so this will be 5 times what this will become. Alright, I'm writing just it over here because I am not having enough space over there. So Sm by Sn, this would be 5. What this would be? 2a minus d plus 5nd divided by, this will become 2a minus d plus nd. Now the problem says that this particular question does not depend on n. So what we can interpret it from here? That is the major thing that is being asked in this particular question. So let's see what does this mean here. So how do we make independent of n this particular ratio? So this says that these are two terms. Let's see, this is first term, which is common in both numerator and the denominator. If we remove this term from both the numerator and the denominator, what would be left to you? You will be left with 5 into 5 nd by nd, right? And then we can say these two things cancelled out and we'll have a ratio 25. But now this ratio is independent of n, right? And that was what is the target that we have in the question. So if I say that if I can use 2a minus d equal to 0, that means we will just be left with 5 nd here and nd here, and the whole term then becomes independent of n. That is the thing which is required in this particular question. So d then becomes 2a, and we know here that a is given to be 3. So this implies d is given to be 6. We are asked a2. a2 is nothing but a1 plus d. a1 is nothing but 3 plus 6. This gives us our answer, particularly 9. Again, you can see that this problem was not difficult. It's just that you have to start solving it, apply what you have learned. Again, this is a question which I have taken from past year IIT JEE Mains, right? Okay, now let's take another problem. So what I'm doing is I'm taking a lot of questions from AP because that is the most famous, or you can say a lot of questions are being asked from this particular topic only, because as mentioned in CBSE, the CBSE is also very good in terms of AP, but as we do later on, so the questions in terms of AGP will not be asked very tough. They may ask tough questions on the AP. That's the reason I'm taking variety of questions in AP. Right, so it says if the root of this particular equation are in AP, then you have to find the common difference. Now something new to learn here as well. So this particular problem has cubic in the question. It says x cube minus 12x square plus 39x minus 28 is equal to 0. Though I am going to cover this thing particularly in your different chapter called quadratic equations, but if it has been asked here, let me introduce you the topic over here as well. So let's take a basic cubic which is given by ax cube plus bx square plus cx plus d, and if I say there are three roots alpha, beta and gamma to this particular problem, so then what is the sum of roots given for a cubic is minus b by a. You have to remember this is a formula. This is completely a formula. If I say product taken two at a time, that is alpha beta, beta gamma, gamma alpha, they are added, this will be c by a. So what I am doing, just see the pattern. First b by a, then c by a, and sign first is negative, then it becomes positive here. And the product of roots is alpha, beta, gamma. Obviously then what would be the next one? Okay, yes, you could guessed it right. Now this time would be d by a, but mind it will be now negative sign. Positive, negative, negative, positive, again it becomes negative over here. Now using this particular stuff again in our problem, don't worry about how we have generated this particular step. We'll do this in detail in quadratic topic. Another thing which we need to learn from this particular question is we are asked that roots of this equation are in AP. Obviously this is cubic, degree is 3, so there will be 3 roots. How to take 3 numbers in a cubic? Alright, so this is the target of this particular question also. So if you have to take 3 numbers in AP, So how are we going to take it? We will not take them a plus d, a plus 2d. We will take them a minus d, a plus d. This is how you take three numbers in an AP. If you are asked to take four numbers in an AP, then the difference would be we'll take a minus 3d, a minus d, a plus d, and a plus 3d. So here if you see in these terms the difference was d, common difference. In these the common difference is 2d, not d. Just remember this particular stuff. Alright. So now let's apply this particular thing in our question and let's see how the question goes ahead. So roots are, let's say, alpha, beta and gamma. So the sum of roots will be alpha plus beta plus gamma. In the question they are given to be, it should be minus b by a. Here b is minus 12, so it becomes 12. And we know that we have assumed our roots as a minus d, a and a plus d. So the sum becomes, d would cancel out. You can see that. I hope you are understanding why we have taken the three numbers as this. Because if you add them, you are just left with a. D cancels out here. And you directly gets the value for a. So a comes out to be 4. There is nothing discrepancy in this. Now what we also need is, we also need to find d, because that is the target. In fact, you are asked to find common difference. Another thing that we can use is alpha, beta and gamma. It is given to be minus d by a. D here is not 28, mind it, it is minus 28. This minus is very important here. So minus 28 by 1, which is again nothing but 28. And what would alpha, beta and gamma would become? A minus d into a plus d, which is a into a square minus d square. This is given to be 28 to you, right? We already know the value of a, so this becomes what? 16 minus d square is equal to 7, right? And if we do this, d square comes out to be what? 16 minus 7 becomes 9, and we get our answer d is equal to plus minus 3. Alright, mind it, there are two particular answers to this. We cannot say that only d equal to 3 is the answer. Alright, but if we try and look at the options, then d equal to 3, this is the answer we are looking for, right? So in this particular question we have learned two particular things. One is the formula for the cubic, and the other thing that we have done is what? How to take numbers in an AP. So if there are odd number of terms, you start from middle term is a and the common difference is d. If there are even number of terms that you want to take, you will start from what? The middle two blocks. These are the middle two blocks, a minus d and a plus d. Just keep on adding 2d here and subtracting 2d here for extending the series. I hope this question is clear now. Alright, so I hope that the speed is not the issue with you people, and in case if you feel that I am going at a fast pace, you can just pause the video and go through it again. That's the reason I'm not taking a live class, just to make sure that you people can comfortably view the videos at your own pace. So there's another particularly question which keeps repeating itself in exams at IIT, JEE Mains, or maybe at other competitive exams, and it's a very simple problem. What it says that the sum of n terms of two series in AP. So first of all, whenever you are given two series in AP, so what do you understand by this? That there are two APs. So there is AP1. So AP1 will have its first term as A1, and it might have, let's say, the common difference as B1, right? There is another AP2 here. It will have its first term as, let's say, C1. Let me just recorrect it. It would have its first term as C1, and it could have its common difference as D1. So this is what has to be interpreted. There are two series, they are not one, right? So they are in the ratio, the sum of first n terms of these two. So let's say if I called one as Sn and the sum of the other as S dash n. This is given to you that n by 2 of these two both series. So this will be 2a1 plus n minus 1 into b1. Divided this by your n by 2, 2b1. So sorry, This is not B1, correct me. So this is what? C1, right? Because the first term of this second AP is C1 plus n minus 1 into D1 again. So this is the thing which is given into your question. Now you are asked to find the ratio of these two particular, this ratio is particularly given to you. So this is 5n plus 4, let's say 6n plus 6. Find the ratio of their 13th term, right? So you want the ratio of their 13th terms. You don't want the ratio of their 13th sums, and that does not make any sense. So what is being asked is T13 by T dash 13, right? So let us first of all see what actually is this particular ratio. So this becomes A1 plus 12B1 divided by C1 plus 12D1. So this is the particular thing which you require out of this problem, right? How we'll do this? We are given this particular stuff here, but we need to find answer in these two terms. So if I see first of all, this n by 2, this n by 2 gets cancelled up, right? What actually is left now is, let's see, 2a1 plus n minus 1 b1, right? And in the denominator you are left with 2c1 plus n minus 1 d1, and this ratio is given to be 5n plus 4 by 6n plus 6, right? Now just compare this and this. Can we convert this into this and this into this? Just see to it. And how you can do this. So if you notice that there are two particular things which are happening here. So it has A1 here, we have A1 here. It has B1 here, we do have B1 here, right? In denominator there is C1, we also have C1 here. It has D1 here, we again has D1 here. So we have those things which are required. The only problem is that here there is no 2, there is 2. Same here, there is no 2 here. Can we divide the both numerator and denominator by 2? That's not a problem. Yes, we can. So now this becomes n minus 1 by 2 b1 divided by c1 plus n minus 1 by 2 d1, right? Now if you compare these two particular terms, a1 and c1, so this is right, b1 is at its place. The only thing which we require right now is that if this particular stuff now matches up to 12, we get our answer. So the thing which is required to be solved here is n minus 1 by 2 should be equal to 12. This gives us the value n is equal to 24 and this is 25. So if we substitute the value here, so if I say substitute n equal to 25, the LHS will get converted to, so this becomes T13 by T dash 13. Now you also have to, just don't forget this, we also have to substitute n in the right hand side. So this is nothing but what? 5 into 25, that is 125, 129. This is 25 into 9 plus 6, that is 225 plus 6, that is 231. That is the answer we are looking for. So that easy this question was, nothing to be done. Just try and understand this particular concept, that how we have just made sure that these particular things are being matched up in the question. That's it. Alright. Okay, now let's take another problem and we'll try to understand another particular formula using this. So if I go ahead and speak the question for you, it says find the sum of first 24 terms. Okay, so I'll just highlighting first 24 terms of an AP where this particular sum is given to you, right? This is given and we need to know the sum of first 24 terms. So what we are being asked here is, let's understand, so what are we being asked is, we need to find S24. So this is what the question is asking us. So S24 we know that is nothing but A1, A2 up till A24. This is what is mean by S24. So now I am going to introduce a new formula to you, which I guess many would be knowing, but let's just revise it once again. So it says that sum of terms equidistant, just listen to it first. Sum of terms equidistant from the ends is equal to sum of the first and the last terms. All right, I understand I understand that आप काफी सारे लोगों को समझ में नहीं आया होगा. Let me take a simple example to make sure everybody gets hold of it. So these are numbers which are written in AP, a simple AP, very simple AP. So this is first term from the beginning. This is called first term from the back, or first term from the end. Second term from the beginning, this you can map with second term from the back. Third term from the beginning, you can map it with the third term from the back. Fourth term from the beginning can be mapped with fourth term from the back. Now add all these pair. So this will give 1 plus 8 is nothing but, if I add the first and the last term, this is 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. So this is what I was telling you about. So the property here is that AK plus A n minus k plus 1 is equal to A1 plus AN. Just remember this property, very useful property, might be used in the exams, right? So I make sure that you understand what I have written here. AK is the kth term from the beginning, and this is the formula for kth term from back. Kth from back, right? It is the kth term from back is not n minus k. Remember this. This is wrong. The right answer to this is n minus k plus 1. Again, you can understand it from here. So for example, if we take the fifth one, this here, right? This is fourth term from the back, 1, 2, 3, 4, and fifth term from the start. So there are 8 terms, subtract 5, so you will get 3, plus 1 is 4, so this is the fourth term from the back, right? Now let us see how we apply this particular thing in this question here. Alright, let's see. So it says that what is given, just again we'll write it. A1 plus A5, A10, A15, A20 and A24, right? So let us just stop here and assume that the AP has only 24 terms. So the first term is A1, right? And the last term is 24. So I just pair this, sorry, I'll just redraw the diagram. So yeah, so this matches, this pair actually matches with A1 is in pair with A24, right? And A5, so what is A5? A5 is the fifth term from the start. What should be the fifth term from the back? So let's do the calculation. A24 minus 5 plus 1. Just see to it what it comes out to be. It comes out to be A20. That means you can pair this with this also. A10 is the 10th term from the beginning. What could be the 10th term from the back? So 24 minus 10 plus 1. Let's see what this comes out to be. This comes out to be A15. Voila. So these two are also our terms which are common. So if I can say that we have different pairs in this particular problem. So the pairs are A1 plus A24, first pair. The other is A5 plus A20, and then we have A10 plus A15, and all of them are equal to first term and the last term, which is A1 plus A24, and this is given to be 2 to 5. This comes reduces to that A1 plus A24 is nothing but what? 75. Now we have got hold of up till this particular problem. Okay, so but what were we being asked? So we were not being asked A1 plus A24, we were being asked S24. Now that problem is very simple. So if we see, this becomes n by 2 A1 plus A24. 24, right? Nothing, you just need 24 terms. So this is 12 into 75. This is nothing but we get our answer as 900, and this is the answer we were looking for, right? So now in this particular problem we have understood the formula of ak an minus k plus 1 is nothing but sum of first term and the last term, right? Okay, now let's take another problem on AP, and again this is a very famous problem which says that interior angles of a polygon are in AP. The smallest angle is 120 and the common difference is 5. Then find the number of sides of the polygon. Alright, so this is a very generic problem that is being asked many times in the paper. So let's understand with again this problem by taking a simple problem, right? So we are talk here about polygon, right? We want to talk about polygons here. It is given that you have to talk about polygon. Okay, so let's understand this by, let's say, a hexagon, or you can say the benzene ring that we are talking about. So there are 6 sides here, right? So this is a regular hexagon, and we need to find the sum of interior angles because interior angles are being used in this question, right? It is, let's say, this angle is 1, this angle is the other angle, and so on. These are 6 angles. So how do we find the sum of interior angles of a hexagon? So let me draw as many triangles as are possible in this particular problem. Just mind the lines, they might not be drawn to the scale. So if I see, this is the first triangle, second triangle, third triangle, fourth triangle, right? So there are 4 triangles which we can draw here. So each triangle has an sum of interior angles is 180. So 180 into 4. Now if I have to draw an analogy कि हम इससे हर बार formula derive कर पाएं. So in hexagon there were n is equal to 6. N means number of sides. आपने यहाँ पर क्या लिया है? 4, right? So whenever you are asked sum of interior angles of a polygon, the formula becomes n minus 2. So this is the sum of interior angles of a particular polygon which we will be using this. Now what we are given that there are n angles, because there are n sides, there are n angles, and all angles are in AP, and the smallest being 120. So this series here is something of this sort, right? And it is given that it is 120, the smallest angle, and the common difference is 125. So this is how this series turns up till an, and this is n minus 2. Okay, I hope it is this particular stuff is clear to you. Now what is the target? We need, what is the requirement? We need to just find n. Simple, right? Very simple. So Sn then becomes n by 2, 2 into 120 plus n minus 1 into d is given to be 5. So this is the particular stuff you are asked to solve. But if you see properly, this would convert into quadratic. So why? Because here there is n here, and if you multiply both of them you will get quadratic. So quadratic will have how many answers? So quadratic will have 2 answers. So you can solve it at home. I am not solving it for you. Just remember that there will be 2 answers here, 16 and 9, if you solve this particular quadratic. Alright. So if there are 2 answers, 16 and 9, so one answer is that you have 2 particular polygons for this particular question, that is one with the 9 sides and one with the 16 side. Let's check whether both of them are the answers or not. So if I take 16, so the last answer angle would be A16. A16 would become 120 plus common difference 5 into 15. So this becomes 195 degrees, right? But now let me explain it to you, or rather you tell me, is it possible for a polygon to have an interior angle which is greater than 180? This angle is greater than 180 degrees. This becomes what we call as reflex angle. We do not take into consideration reflex angles. So 16 answer is wrong. We cannot have 16 here. Let's check this with 9, the 9 side polygon. This becomes 120 plus 5 into 8. So the maximum angle here is 160. Perfectly possible, no problem at all. So there is only one answer to this question, which is polygon with 9 sides. Answer is only 9. Okay, let's take another problem. So this particular problem is taken to make sure that you understand another concept of AP. So what it says that if A, B and C are in, let's say, AP, right? So if I multiply them with a number K here, K here, alright, then they still are in AP, right? Even if I divide all these numbers by K, then also all of them are in AP. Another interesting property, if I add K to all three numbers, then also it's a AP. Why? Because you can very clearly see, if you just subtract these two, what you will get? B minus A. Subtract this, you will get C minus B, same as the common difference of the original AP. So similarly, if I subtract K, then also the terms remain in AP. Again, AP, no problems at all. Very, very interesting property. And I have taken this particular question specifically to make sure that you understand this particular concept. So let's apply it here. It says that these three terms are in AP. Alright, so just let me write these three terms for you first. Alright, so these are the three terms and they're very beautifully written in terms of math. So how beautifully? Let's see. There is a pattern in all these three terms. If I talk about a pattern, there is a cyclic pattern. See this term. It says B plus C and there is minus A. Then the cycle is being rotated. So understand it this way: A, B and C. So the first term was where B, you go to C, then you go to the third term but with a negative sign. So you started the first term with B, now you have to start the second term with C, C, add second term, then subtract the third term. And again, if you see here, the pattern is, now you will start from A, add the second term, subtract the third term, right? And the term which has been subtracted is there in the denominator. Isn't that a very good pattern to remember? So make sure that whenever a sequence series question is given to you, you try and analyze the pattern given in the question. This will make your work much easier. Now let us see how we apply this particular thing that we just did here in this question. We want to prove by using this that these are in AP. We want to prove that one by A, 1 by B, 1 by C are also in AP. So our target is to make 1 by A here, 1 by B here, 1 by C here. So let us see how we'll do that. What if I do this particular stuff here, that in the first term I am going to add 2 and in all these terms I add 2. I'm not writing the terms, but I am just hoping that you also understood what I meant by plus 2 here, right? So what do you understand by this? So let's do the basic addition here. So it becomes, if I take the LCM, what it will become? B plus C minus A plus 2A, A by A. Let's see the other terms. What should it be? Yes, it should be B, absolutely. What should be the third one? B, C is here plus 2. So what did we? Exactly. So A plus B plus C by C. Now notice that by adding 2, what we have written here, that they still remain in AP. So up till now there is no problem if I say that it's still an AP. Absolutely fine, right? Now let's take it to the other level. Now we know that numerators in all these three terms are same. What we had said here, that if you divide all the three terms by a common number, then also they are in AP. So I divide all the three by A plus B plus C. So what will be left with? A by B, 1 by A, 1 by B, and 1 by C, and this does not change the property that they are in AP. Hence proved. Nothing need to be solved. What generally students do here is that they know the formula 2B is equal to A plus C. The general formula for 3 terms to be in AP, and they start immediately applying this. By the virtue of the question only, you can see that if you start applying this over here, ये बहुत लेंदी बनने वाला है, ये इतना आसान सवाल नहीं रहेगा. But if you see, we just did this particular question in 3 straight steps. Over. So understand the beauty of this concept, that this particular concept can make a question very simple, very easy to use. आपका question 5 मिनट में जो solve होना चाहिए था, now it will get solved in within a minute, and that is how you beat the exam. आपको exam में सिर्फ question solve करना नहीं आना चाहिए, उसको time frame के अंदर, और अगर possible हो तो 1 मिनट के अंदर solve करना आना चाहिए, और ये उस particular type का problem था, right? Okay, now after doing questions on arithmetic progression, let us now move to geometric progression, right? So let's see how to solve questions which are based on geometric progression. We know that the basic understanding of geometric progression, I hope, is clear to everybody, that how it is being represented, that every term, just a sec, so every term here is written as A, then a constant is multiplied, AR square, AR cube, where this particular R is known as the, what we call as common ratio, right? This is, I guess everything is clear to everybody. So, and these are the 2 basic formulas for geometric progression. This is the formula for the nth term, where A is the first term and R is the common ratio and is the nth term. And this is the formula for sum of first n terms of a GP, which is represented in this format again, right? So let us take a very simple problem to understand how to apply the formulas of nth term and nth summation. So in this particular question, it says in a GP of positive terms. So first of all, what do you understand by this word positive term? So let us start understanding the question from each and every term. So positive terms. So if you see that positive terms, this is positive, this is positive. In fact, I would rather say this is positive, this is positive. So if this is positive, the first term is positive, that means A is positive. Then the second term is also positive, that means this is also positive, given in the question. So what this can imply? So this implies that if A is positive and AR is also positive, that means R is positive as well, right? So very important thing here. So if a GP is given where the terms are positive, that means the common ratio is positive. All right. So because common ratio can be anything except for 0, but or 1 by 0, which is not a number anyway. But if we talk about this particular problem, it is given that R is positive. So any term is equal to sum of the next 2 terms. So for example, what do you mean by this? A1 is equal to sum of its next 2 terms. So next 2 terms would be A1 के बाद 2 terms कौन सी आएंगी? A2 और A3. So A1 is equal to A2 plus A3. This is what is given to you in the question. Or in fact, this is even valid for A2. A2 is the sum of its next 2 terms, right? And so on, you can go on writing and writing over here, right? So there is no need. In fact, I could also say, generalize this as an is equal to an plus 1 plus an plus 2, right? This is the generalist form which I can write for this particular question. Nth term is equal to n plus 1th term plus n plus 2th term. This is what is given to you in the question. But we can solve this particular problem from this particular stuff only. So let's say A1 is the A, the first term. A2 then will become, yes, AR, correct. And A3 then will become, perfect, AR square. So this is given to you. And if we solve this, you can see that A will get what? A will get cancelled out. So if A gets cancelled out, what we are left with, 1 is equal to R plus r square, which is quadratic in terms of r. So this is the quadratic which we will get, and we'll have two solutions for each quadratic, because we know that from the fact that quadratic should always have two answers, irrespective whether they are real or complex, which we'll study again in the quadratic component. So if I have to solve, this will become, just to revise, what the formula is, minus b plus minus root d by a. So if you do this, this becomes plus minus this by 2, right? So the value of r we get is minus 1 plus minus root 5 by 2. Obviously what we were asked, positive terms, and we have already decided that r is positive, so we will, this particular answer, so we will check off this answer. Why? Obviously for the reasons that it is a negative term, this is a negative term, so r becomes negative, this is less than 0, we do not require this. Alright, so our answer is r is equal to minus 1 plus root 5 by 2. Simple. Let's take another problem. Okay, so this is again a very standard problem, and in fact you can find it in each and every book, even that is available in the NCERT. So why I'm taking this is because it is that common, so that is the reason I'm taking this. And we just need to understand, and I'll quickly go over through this particular question. So it says 5 plus 5, 55 plus 555, and I'll used to call this problem as 555 problem. 555, if you remember, was a Nirma bar that used to come. So I call this particular problem as 555 problem. So we need to find the sum of this particular series. So let's see how do we find it. So the traditional method of solving this problem is that first of all you take what, 5 common from this particular series. So this will become 11, this will reduce to 111, and so on, right? So the last thing here would be 111 repeated n times, right? This is the first step that you need to do in this problem. The next step is you multiply and divide by the 9, right? So remember that you cannot just simply multiply by 9, you just have to multiply and divide, obviously, right? And then this 9, let's see how we write 9 here. 9 can be written as 10 minus 1. This 99 can be written as 10 square minus 1. This 999 can be written as 10 cube minus 1. So you can see a similar pattern now again. There is a pattern. So what would be the last term, nth term? Just think of it. Yes, absolutely. So 10 raised to power n minus 1. So this is the nth term, because it will contain 9 n times here. And just now if you see, if we were to solve this, so the series then can be written as 10, 10 square, 10 cube. I am just collating the GP part of it. 10 raised to power 9. How many times the minus 1 factor comes in? So yeah, n terms, so each term contains minus 1. So 1 repeated n times is minus n. This becomes 5 by 9. And now if you see properly, so this particular part is GP, normal GP, right? And GP's formula is, this is what it is written here. So formula then becomes A is 10, common ratio is again here 10. So 10 raised to power n minus 1 by 10 by 9, this is 9 minus n. So this is the answer to this particular problem. It's a very famous problem, even included in NCERT. This is how you have to solve. In terms of this, various questions can be built up here. For example, you can be asked to solve these kind of problems as well. So don't worry, just what you need to do is, this is 5 by 10, this is 55 by 100, this is 555 by 1000. You can, the series then now will become, you can imagine that if you take 1 common or 5 common here, these will be 0.1, 0.11, 0.111. This, the lower one will be 9 by 10 and so on. So you can just do that in the similar fashion. So I'm leaving that part to you people, right? I hope this is clear. Okay, so now let us quickly move to the other problem. Again, this is a NCERT problem, I guess, but a very important one to understand, because we'll study this particular topic here in the functions topic. So this is something called functional equation. right? So we'll do that in the topic when we'll come to functions, but for now let us see how to solve this particular problem, even if you do not know what is a functional equation. So fx is a function which satisfies this particular equation. You just treat it as an equation, right? And f1 is given to be 3 to you, and also what is given is x is equal to 1 and fx is equal to 120. The other reason that I have taken this problem is that I want you people to be very familiar with this particular sign over here. So no need to bother about what this sign is. We have already done ample questions above, and if we just go on, if you are confused, just start writing the meaning of this particular stuff. So this is actually this, right? Am I right? Any confusions till now? So this is the summation sign, and you start replacing x starting from 1 till n using all natural numbers. This is what is meant by the summation sign. Now we know that f1 is 3, so I know this part, that this is 3. I know this part, right? I need to figure out all these remaining parts, and then only we can use this particular equation number 1, right? We also know that f1 is 3. Just try and find out what can f2 be written as, and try and use this particular stuff over here. So f2 can be written as what? F of 1 plus 1. And what would be f of 1 plus 1 using this? So we can split this into f1 into f1, or we can simply say 3 square. Can you find a pattern over here? There's a pattern, complete pattern over here. So if you start finding f3, f3 could be written as f2 plus 1. Again, I can write it as f2 into f1. What is f2? We have already found f2, which is 3 square. f1 is 3. This becomes 3 cube. So if there was, let me just tell you the pattern. 2 here, power 2. 3 here, power 3 here. So can I say that fn will simply be 3 raised to power n? By the same logic. I hope this is getting clear to you. I'm not running that fast. So if we just use all these here, so this becomes 3, 3 square, 3 cube. Last term would be 3 raised to power n. This is 120. And if you see this, what is this? A normal GP, which can be written as 3 into 3 raised to power n minus 1 by 2 is equal to 120. I'm leaving the component to be solved for n on your behalf, because that's simply pure calculation, right? So this is how you need to solve functional equation. I'll repeat the part which is important in over here. Try and just understand how we have splitted this stuff. Find patterns for this. So for patterns I mean, क्या मतलब क्या है कि आप इसमें छोटी छोटी वैल्यूज डाल के देखें, rather than कि हम इसको समझने में दिमाग खराब करें कि ये क्या चीज है. आप इसमें x की वैल्यू 1, y की वैल्यू 1, x की वैल्यू 2, y की वैल्यू 1 डाल के चेक करना शुरू करें. Each and every questions can be solved using this particular step, right? Now let's move to the other problem. Okay, now let's see what is this problem all about. Again, I have taken summations, so because what I have understood in my teaching career that students, as soon as they see the summation sign, आपको घबराहट हो जाती है. मैं वो घबराहट खत्म करना चाहता हूँ. आप आगे से समीशन साइन से कभी ना घबराएं, इसलिए मैं ज़्यादा से ज़्यादा क्वेश्चन समीशन साइन के ले रहा हूँ. और दिस इज द ट्रेंड दैट आई टीच. जो मुझे लगेगा कि आपको जहाँ मुझे लगता है समझने में दिक्कत होगी, मैं क्वेश्चन हमेशा उसी चीज़ के ज़्यादा लूंगा. सो लेट्स अंडरस्टैंड दिस प्रॉब्लम. एन इज द nth term of our GP of positive terms. Again, so it is specifically given to you that terms are positive. So इससे हमें क्या मिल गया? That we know that R is positive, right? All right. So A, now this let this part be जो हमें दिया हुआ है. एक बार जरा सिंप्लीफाई करके देखें इसे. तो ये हुआ n goes from 1 to 100. A to n is equal to alpha. अगर आपको याद हो, अभी हमने AP में ही सिमिलर टाइप ऑफ प्रॉब्लम करा था, जहां पर हमने ये क्या डिनोट करा था भाई, ये कौन सी टर्म्स हो जाती हैं? 2n. सो 2n आर एक्चुअली इवन टर्म्स. अभी हमने करा ये क्वेश्चन, राइट? सो ये क्या बन जाएगी सीरीज, देखें आप, A2 A4 A6 up till A200 एंड दिस इज एक्चुअली नथिंग बट ये हमें आपको क्या दे रखा है, अल्फा। सिमिलरली अगर मेरे को बीटा निकालना होगा तो बीटा क्या बन गया, ये वही पुराना क्वेश्चन देखा जाए हमारा, A3 A5 और अप टिल 199, दिस पर्टिकुलर थिंग इज गिवन टू बी बीटा, राइट। बट पुराने क्वेश्चन में दिस वाज AP, नाउ दिस इज GP। तो दिक्कत क्या है, बात तो आसान सेम ही है ऑलमोस्ट, बस सिर्फ फॉर्मूला ही फर्क तो हुआ। देखें कैसे सॉल्व करा जाएगा। हम फिर से क्या एज्यूम कर लेते हैं, फर्स्ट टर्म इज A, common ratio is R. There is no harm in assuming this in every question that you can take, right? So ये क्या बन गया, देखिए पहली टर्म क्या होती, A2 क्या हो जाएगा AR, ये क्या हो जाएगा AR क्यूब। आप फॉर्मूला देख सकते हो, मैंने यहाँ भी लिखा हुआ है। nth टर्म में R की पावर एक कम, राइट। सो 200 में पावर क्या आएगी R की, एब्सोल्युटली R की पावर होगी 199। दिस इज गिवन टू बी अल्फा। अगर मैं इसी को थोड़ा सा यहाँ पर रिजॉल्व करने की कोशिश करूं तो क्या बन जाएगा, देखो AR कॉमन हो गया, बचा क्या अंदर, R स्क्वायर अप टिल R रेज़ टू पावर 198 इज इक्वल टू अल्फा। एंड आई कैन सिंपली से दिस इज माय फर्स्ट ऑब्जर्वेशन फ्रॉम हियर, राइट। नाउ सिंपली सॉल्व दी बीटा कॉम्पोनेंट। बीटा को अगर देखें तो ये A1 तो क्या हो गया, A ही हो गया। R ये क्या हो जाएगा, क्यूब वाला, जो सॉरी क्यूब कह रहा हूं, A3 इसकी पावर कितनी आएगी, स्क्वायर। A5 में 4 और सिमिलरली 199 में पावर क्या हो जाएगी R की, 198 इज इक्वल टू बीटा। अगेन आई कैन से दैट व्हाट आई कैन टेक कॉमन हियर इज A कॉमन ले सकता हूं, तो आपका कुछ इस तरीके से ये बच जाएगा। और मुझे अब लगता है दैट एवरी वन ऑफ यू मस्ट हैव पिक्ड द क्वेश्चन। So this is your first, this is your second. Obviously you can see the pattern that if I just multiply this by R on both sides, so this particular stuff जो यहाँ पर ये लिखा हुआ है, ठीक है, ये क्या बन जाएगा, ये पूरा का पूरा अल्फा बन जाएगा, right? So this becomes alpha is equal to beta into R. R then comes out to be alpha by beta, and this is the answer to this particular problem. Again, if you can see that question में समीशन साइन की वजह से it was looking a bit difficult, पर अगर आप उसको सॉल्व करना शुरू करते हैं तो ये क्वेश्चन बहुत आसान है। Again, this problem has already been asked in AIEEE exam. So again, just watch out कि इसका स्टैंडर्ड क्या है। हमें टफ लगता है देखने में, बट ये क्वेश्चन टफ नहीं है। Okay, all right, so let's take another problem to understand and continue with our GP effort. So GP में आपको इस तरीके के क्वेश्चन भी पूछे जाते हैं, and these are very common apart from your JEE Mains, BITSAT और मणिपाल जैसे एग्जाम्स, VIT जैसे एग्जाम में these kind of questions are very common because ये बड़ी जल्दी सॉल्व करे जा सकते हैं। तो हमसे ये पूछा जा रहा है that you need to find the sum of this particular series over here, right? So अभी फिलहाल मुझे इसमें कोई पैटर्न नहीं दिखता, I cannot see any pattern in this particular problem, right? But yes, there is a definite pattern. कई लोग कह रहे हैं कि there is a pattern. Yes, let's see what is the pattern. 3, 9, 27. So I can see some pattern. This is 3 square, this is 3 cube, so I can see that there is some pattern. So the pattern, let's say if I rewrite this as, so this becomes 1 plus 4 by 3, this becomes 10 by 3 cube, this 28 by 3 cube, sorry, and this will be 3 square. Let me just correct it, right? Okay, so we know that there is a pattern, and अगर मैं सिर्फ 1 by 3, 1 by 3 square, 1 by 3 cube वाला component लूँ, so this is a GP, but the problem is with the numerator part. Let's see how we can resolve this numerator part also. I know that some people would have been able to solve this by seeing this. This is for those who were not able to do so. Let's see. 4/3 को आप क्या लिख सकते हैं? 1 + 1/3। ये मुझे पैटर्न कहाँ से, ये मुझे कैसे रियलाइज हुआ? आप नोटिस करो दैट न्यूमरेटर इज ऑलवेज ग्रेटर देन द डिनोमिनेटर बाय 1. So in this case denominator is 3, so the numerator is 4. Here denominator is 9, so the numerator is 10. So again I can write the third term as 1 + 1/9. Similarly I can write 28/27 as 1 + 1/27. And similarly if I continue the pattern, can you say that what will be the nth term? Nth term would be of the pattern 1 + 1/3 raised to power n minus 1. Okay, so here is a bit of difficulty in understanding what should be the power, right? So let's take this part again. So we need to find nth term here. आपकी second term में what is the power of 3? 1. Alright. In second term, what is the power of 3? 2. In fourth term, what is the power? 3. So in nth term, the power should be 1 less. Very simple, right? So it should not be 3 raised to power n, it should be 3 raised to power n minus 1. So Sn now becomes 1 plus 1 plus 1/3 plus 1 plus 1/9 and so on till 1 plus 1/3 raised to power n minus 1. So how many times 1 is getting repeated? 1 here, 1 here, 1 here, and there are n terms. So n plus 1/3, 1/9 कब तक चल रहा है ये? 3 raised to power n minus 1. Alright. I have seen students committing mistake again at this step, that how many terms are there from here to here, right? They generally say in n minus 1 terms. Alright. I hope किसी को ये confusion नहीं है कि इसमें n terms है. n terms तो नहीं हो सकते because starting वाली term में यहाँ पर 1/3 था ही नहीं. So confusion आती है n minus 1 terms या फिर n minus 2 terms. तो बड़ा ही obvious आंसर है. आप सोचो क्या आंसर होना चाहिए? What should be the answer? How many terms are there in this particular series? Obvious ही बात है ना. आप यहाँ देखो, this is the term 1, right? This is term 2, this is term 3 and this was our nth term. तो मैंने सिर्फ पहली वाली टर्म में तो GP का component नहीं लिया. The GP component starts from T2 and goes till Tn. So if you just leave the first term from T2 to Tn, how many terms are there? n minus 1. So this is the right answer. So for this, what is the formula that we are going to use? A is 1/3, R is 1/3, and the value of n that we will be using is not n, it will be n minus 1. So the answer then should become something of this sort: n plus 1/3, 1 by, just a second, I'll replace R. So this is 1/3 raised to power not n, it will be n minus 1 minus 1 divided by 1/3 minus 1. Alright, so this term will be negative. You can send the negative above and then do the calculation. So again, I'm leaving the calculation part to you people. Alright. Alright, let's take another problem which says that if the roots of the cubic are in GP, then you need to prove this. We have already done a similar problem in the AP where we talked about the roots of a cubic. So that is the reason I have already mentioned the roots in this particular problem, which are like this. We know this, right? So sum of root is minus b by a, product of roots taken two at a time is c by a, product of roots is minus d by a. So there are three roots, right? So in the AP component, what we did, we took three roots as a minus d, a plus d. So same kind of logic is here as well in GP, where how do we take three terms in GP is defined by this particular logic. AR, A, AR. Here if you see that common ratio is R. If we are to take four terms in GP, they will be taken as AR cube, A by R, AR square. And if you notice here, the common ratio is not R, it is R square. So let us apply this trick in this particular problem. So there are three roots. Since A is already used in the question, so let's say we use that the first term is T by R, right? R is the common ratio, T and TR. So we'll use these three roots. I'm not using A by R, AR, because A is already used in the equation. So if we go on and start using each of these particular equations, we'll find three equations. But first of all, understand what is asked in the equation. So our question says we need to prove this particular stuff. Does it anywhere say that we need to find the roots? We are not asked to find the roots. That is the interesting part. So here, in spite of finding the roots, our target is to eliminate roots. We want the root should not be there. We will not find the roots. In fact, we'll eliminate them. So how do we eliminate them? Let's see. So alpha plus beta plus gamma will become T by R plus T plus TR is equal to minus B by A. And if you calculate this, this will become what? T by R 1 plus R plus R square is equal to minus B by A. So this is my first equation, right? Let's solve the second equation. Second equation says alpha beta. So alpha beta is product of these two terms. So this will become T square by R. Product of these two is beta R. So this is T square R. This will be what? T square only, right? And this is C by A. So again, if I solve, this becomes T by R 1 plus R square is equal to C by A. Okay. If I just use these two problems, if I can say that T by R into 1 plus R square is already being utilized, this particular stuff is already being utilized here, right? So this just becomes T into this entire particular stuff, which is nothing but minus B by A is equal to C by A. So from here on, I can say the value of T is what? Minus C by B. Though I'm still left with one particular equation, which is this particular here. So if I try and solve it here, okay, so what this would be alpha beta into gamma. So that means we need to multiply all these three. So this will be R will get cancelled and we will just get T cube. That is the importance of taking this particular. Okay, so T cube becomes what? Minus D by A, right? And from here we already know what is the value of T. So just put it over here. So this becomes minus C by B whole cube is equal to minus D by A. And now we can say that this is C cube A is equal to B cube D. Minus minus gets cancelled out, and this is what we were actually required to prove. So this is a very important problem in terms of how do we actually solve this problem where we are asked to eliminate roots, not find the roots but eliminate the root. Also how to take terms in GP. So if three terms are required, we will take A by R, A and AR, right? Why we have taken so? This is the logic that if we multiply them, what you are getting? You will just get T cube, that is single variable. You will not get R over here, right? Let's move on to the next problem. So now the next problem that is here is based on the most important concept of this particular topic, that is sum of roots of infinite GP. So this is the formula that I have highlighted over here, that sum of infinite terms of infinite GP is A upon 1 minus R, provided that the value of R is between minus 1 and 1. So you cannot say something and apply this formula everywhere. So you cannot say 2 plus 4 plus 8. So we know that this is in GP where first term is 2 and common ratio is again 2. And if I say this goes till infinity and you directly apply this formula, just check it out. This formula will be nullified in this case. So this becomes 2 upon 1 minus 2, which gives you minus 2. Completely absurd, because these are all positive numbers, and if they are added till infinity, the answer should be approaching infinity, whereas we are getting a negative number. So keep in mind that whenever you apply the infinite GP formula, the common ratio must be between minus 1 and 1, not even minus 1, not even 1. Okay, the first rule. Now coming back to our question, again I have taken a question which at the onset looks very difficult and very challenging. Right? Why it is challenging? First of all, there is a summation sign here, and now limits are also being introduced. Though I have not taught you limits as of yet, but limits are not required in this particular problem. We just need to understand the meaning of the limit. So variable of limit over here is n, right? This is the variable of limits. And if we see, this is the upper power of, or the upper variable of the summation. So I can rather say this particular thing can be reduced to this, that summation goes from I equal to 1. So the value of n can be just simply replaced by infinity. So instead of using in limit, you can directly use this particular stuff over here. So this is something like this. This is sk which is given to you. So you can see that there was no use of limits here. It was just given to you so that you start thinking that this is a difficult question and you miss out on this. But there is no need to get into the depth of the limits. So now just see how we are asked this problem and how we are going to solve this again. So again we say that for summation I starts from 1, it will go till infinity. That means infinite natural numbers till infinity. So the series is something of this sort. Just write first two terms just to understand what it is actually all about. Something of this sort. Don't worry about k. K is constant in this particular question, right? For this particular component, k is constant. Don't worry about it. And this goes till infinity. For me, what I see is what is happening. Let's see. So rather than I say 1 upon k plus 1 every time, I take that this is equal, let this equal to a. Now comprehend it. So this actually becomes this, which is very easy to comprehend now, right? So it is infinite GP where the first term is a and the common ratio is also a. So sk should be a upon 1 minus a, right? And now you substitute the value of a. So this becomes 1 upon k plus 1 by 1 minus k plus 1. And if you try and solve this, what you will get? K, sorry. So you will just get 1 by k. That's it, right? So the entire thing, that difficult sk which was given to us in the question, is nothing but 1 by k. Complete stuff is given to be as 1 by k. And now just imagine what is being asked of you. You are being asked to find summation I equal to 1 to n k times sk. So nothing is left. Just put sk. So 1 by k summation. This gets cancelled out. You are just left with summation 1. That means 1 will be written how many times? N times. So the final answer then becomes nothing but n. That's it. That easy this problem was. Alright. So never get affected by what you get in the question. Try and understand what is given and why it is given. So limit here was not a very important concept. We just replace the limits on the upper value of summation. That's it. That was the only trick in this particular question. Okay, so now let us take the last problem for today's session. It says that find the largest value of the positive integer k for which this particular value divides this particular stuff, right? So now let us see what does this means to you. Can you just at the onset say this is a GP? Now this should be very obvious to you people. So this is GP, right? So if I say this is a GP, so I can say this is having how many terms? 127 terms or 128 terms? Just think of it. So people who are saying that this contains 127 terms is actually wrong. So 127 is the highest power of n. It starts from where? 1. and there is also a term ahead, so there are total of 128 terms. So you need to find sum of 128 terms. This is what is given in the question. So if I say S128 is given to you as 1 plus n square up till n127, right? No matter what is being asked in the question. So see, you are asked to find the value of k, which is not anywhere given in this given statement, right? Don't worry about it. Just simply solve what is given to you and what you actually know all about. So this is what S is equal to S128. We know how to use this. This is the formula that I've also written in front of you. So this actually becomes, can I say this? Or you can say it reverse also. This is no problem. Don't bother too much about this. So both of the formulas are correct, right? Now we need to find n raised to power k plus 1. So we need something of the sort n raised to power k plus 1. This is the target. Do we have such sort of term right now in S? I again write the S component for you. This is the S count, but we do not have something of this sort right now. We try to convert anything to this format. How we can do so? If we see in the numerator, this is a square minus b square. How a square minus b square? Let's see. Can I say this is like this? Right? Now we have got what is actually required. We wanted something of this particular term. Here it is. Right? So if I say I have to divide this particular series by n raised to power k plus 1. So what is the highest power that you can get for this particular k? I hope you have got your answer. That is 64. Why 64? Because I can go on and further break this term into n raised to power 32 minus 1 into n raised to power 32 plus 1. It will also be divisible by n raised to power 32 plus 1, but we are asked the largest possible value of k, so that becomes 64. Right? The other aspect to this particular problem is this particular term divisible by n raised to power 64 plus 1? For divisibility, what we need to check is that this particular term over here, this numerator by denominator, should be an integer. Then only I can say that it is completely divisible. This should be an integer, which it is. Why I can say that this is an integer? Because if n is an integer, which is though not given, let's assume that n is a natural number over here. So if n is an integer, what does this represent? Can you tell me what does this represent? Can I say this is S64? Just see this component again. When this was written, you made this into this. This 128 has now been reduced to 64. That means this is nothing but sum of 64 terms of a GP. So I can say S64 is nothing but 1 plus n square up till n raised to power 63. And if n is an integer or a natural number, this definitely will be an integer. Hence I can say this will definitely divide this particular term, because this we will get this as an integer part. So the maximum value of n, or sorry, not n but k, that we are looking for is 64 in this particular problem. Again, a very easy problem to solve. Looks difficult at the first, but again, nothing to be done. Only a 3-step problem here. Right? So by this topic, we end our today's class. We will start the tomorrow's class by getting into arithmetic means and geometric means. Maybe the tomorrow's class could be of a 2 hours duration, because we have still a lot of many topics to be covered in this particular chapter. So be focused. I will also be giving you some assignments which you need to do for your revision and practice. The sheets will not contain more than 100 questions any given day, because I understand that you people need to do physics and chemistry as your subjects, which are very important. So only 100 questions will be given to you on a daily basis, not even 100. So what I'll do today, I'll send you a sheet which comprises of questions on AP and GP only, right? Okay, so for sheets, don't worry. As I've already mentioned, we'll be sending you sheets over your email accounts that you have provided us. In case people who are new to this and they have not filled up the form, what they can do is go over our website over here, which is mentioned, that is www.mathongo.com. Go over there, fill the form, right, and we'll get your email ID and I'll send the sheets for this particular lecture over the mail, right? Do fill your mobile number and as well, because we might be sending you details in case there is any abruption in the schedule of the videos. Also, I'll be sending you a feedback form. Please fill it so that I can get to know this quality of my own videos, whether I was a bit fast or a bit slow on the videos. I'll try to adjust according to the requirement of you people. So I'll be sending the feedback form along the mail that I will be sending for the worksheets. Just fill that so that I can make better videos for you people. So thank you for your time. See you tomorrow.